Uh, dim the lights a little. All right, so today we're going to focus on cloud computing, mostly cloud security. This is normally a course on its own. I did write a class for cloud security that's part of cloud administration certificate, but it has never gone through for approval yet. We can't write so many classes without having the faculty support, meaning that the people to teach it. So that's why that certificate it's been pending for a little bit of time. But so this chapter, this particular unit, we're going to focus on the type of cloud. As most of you are going to be in the field, and this is a huge area that's deficient in security because cloud products are pretty consistent now as far as the services that's provided and how it's used. It is very common. However, it's just, I think a lot of us are very used to the internal IT practices and systems. So what you see some transitioning in how cloud security can be rapidly changing and the capability in cloud computing. Most of the data center, as you know, they're hosting web services along with infrastructure services. So many companies are renting servers, either with AWS, Microsoft, or Azure, and also Google, right? But you do have the smaller cloud products and companies, and then you have the security company that governs some of the services behind it. So we'll take a look at like the different type of products and how we scale, along with the type of technology that you can implement to assess cloud and making sure that it is secure. So if you have additional certifications in AWS, in Azure, or even GCP, right? Google Cloud Platform, which is mostly for development purposes, it is definitely useful in the field. They are always looking for security administrator in cloud area. So having additional certification will be useful. So as we learn in some other classes, right, you might have heard about cloud computing. When cloud came out years ago, we always felt like it was very new and a lot of people didn't understand what it was. But cloud products, cloud technology has been around for a long time. It's just we never put a term for it, and how that can be implemented quickly and easily. So over the last couple of the decades, you do see some quick improvement in cloud area. So the basically cloud services allows you to utilize other people's hardware or data center, as you know, to be able to support the type of services that you need. For example, web application that everybody has it, right? But let's say that you don't have the IT team to be able to support that. You don't have the technology, the servers to be able to do that. You can quickly adapt the service through AWS. The downside in cloud is that it's dependent upon internet connection. So if you are getting data from your data storage in the cloud, if you lose your connection to your cloud center or your cloud services, then you are going to be in trouble, right? So let's say that my database is with AWS, and in my area, I would have a storm that's coming through and I have power outages and internet connection outages for 2 weeks. That means that I have to rely on some way to connect to my cloud in order to pull my customer information or inventory information. So therefore, you often see that cloud centers are in the opposite side of the actual physical location. And this is part of the physical security. So this is what we would see. And the resources that cloud provide is going to give you a vast variety of things. So you do have options to go with the service and based on the cost, right? The whole point in getting cloud is to lower costs in the overhead of the systems that we have to carry within. So cost effectiveness is one of the big area. We do see a lot of improvement in cloud security, especially with access management. So you do see that, but it is very, very important to emphasize that your contractual agreement is really going to tell you the responsibility in how you manage security for the cloud. So in the past, a lot of companies assume that, let's say, if I rent the server and I put my resources on it, it becomes the cloud company's responsibility. It's like renting a car and you're driving it, right? But you still have to be responsible for insurance for your car. If the car breaks down, the company is liable in some extent. So it's really coming down to a lot of the contract. And lately you do see it's about 50-50, or even the company itself who's leasing the cloud is responsible for the majority of the security component. So if you don't have security resources for your cloud services, you have to be able to buy that service. So that's additional cost to the actual cloud service that you have. For example, if you want to run a website, right, for your company, or a web app, and you don't have the security professional to do that, then you would have to pay for additional fees, of course. So let's go through and answer some questions. So cloud computing really pertains to any computing services that's delivered to the customers, right? I could be a customer that I own a company, could be an enterprise like Walmart or even Moreno Valley College. And that would require network connectivity. So I need to be able to connect to my cloud data center, right? My cloud service provider, like AWS, which is owned by Amazon, right? Azure, which is owned by Microsoft. Your Google G Suite, which is what you see with Google Cloud Platform. When you're using Google productivity software like Google Sheets or Google Doc, right? Those are the applications that exist via cloud applications. And then something like Microsoft Office 365 Suite that you would use, or email. So there are a variety of services that we can incorporate in our daily operation as a business. You can use it for web application, like what you see with the last two products. You can use AWS and Azure for infrastructure. Let's say that I want to expand my network, but I don't want to spend millions of dollars buying equipment. And then also on top of that, I need to hire the people to maintain it. Then I can use cloud as an infrastructure. That means that I can put my servers, the roles of my servers on the system that is owned by AWS or Azure. Now, when you're looking at AWS products compared to Microsoft products, definitely different UI, but you are going to have instances. So whenever I interview people for cloud, I see some stuff on their resume. I'm always interested in how deep they go on the cloud, as far as, administering it, being able to secure it, and so on. So when I start asking questions, a lot of people know what cloud computing is, right? What its purpose would be, some of the product options that you can go with, but a lot of the times they're not very thorough in how they use the cloud. So in cloud technology also exists virtualization. Like you would have virtual machines for your servers on that cloud. So when you're renting a system, usually they would say that, okay, if you want a quad core server with 8 GB of RAM, this will be the cost, right? Usually that's minimal. And then if you want more processor and more RAM and more drive space, like a terabyte, like a powerful computer that you would see, that would be a different tier, right, in cost. So it's like renting a car. You can get a super compact car, you can get a sedan, you can get an SUV XL, you can get a sport coupe, you can get luxury car, you can rent different type of vehicle to drive. And it is the same thing in IT for us to rent cloud or to get cloud service. So when you're looking at a company, for example, in question 2, DesignCo is using Adobe Creative Cloud, and some of you are using this here for your classes, to create art design for products. So I can make flyers, I can make banners, I can make a lot of different things, or I can even make drawings. And then also Adobe Suite allows me to do other things, right? Like you can use Premiere, you can use lots of different things for like, you know, video and images and so on. And with that, you also see AI, generative AI incorporated. So it asks you what type of cloud service model is Adobe Creative Cloud, and that will be software as a service. So when we're looking at Google Suite or Microsoft Office 365, those are SaaS, right? Software as a service. Now, Microsoft, you have to pay per license per user. So I would pay per seat. So let's say for Moreno Valley College, if they have, let's say 10,000 students, and 5,000 staff and faculty member and administrators, that's 15,000. So when you're looking at that, Microsoft would charge them per seat, let's say $100 per user, and then you add that up. So the most cost that you see is actually pouring into software compared to hardware, because hardware is a capital cost where you pay it upfront one time, right? And it depreciates over time, where software continues to be charged, right? And every so often, every year, every user, you have to pay for that. And then when you upgrade, when they change their product, you have to pay again for the license. So that's why the cost for technology is huge. So that's for number 2, we would say that software as a service. So make sure we know this for our quiz, our final. I'm sure you've seen this in like CIS 25, 27, and other classes. It's just cloud is here to stay, and they're going to be with you when you go into the field. So you have to be comfortable with the terminology and the technology that's available. Okay. So for number 3, it says, what type of cloud service models allows the user to retain control and are responsible for maintaining, upgrading software and operating system? So let's say that I want to run servers, Microsoft Windows servers, or even I can use Hyper-V, where I would be able to use thin client. You guys know what thin clients are? They are just smaller scale computer. Usually they are in small boxes, so minimal RAM, minimal processor, right? We don't need a lot of computing power for general operational needs like generating, you know, documents or Excel spreadsheets or checking email, compared to something that you would do in design. So a lot of companies, they would use thin client. And what we can do is we can deploy everything from the cloud. I can have an application server, right, that's pushing all the applications that the user needs to the thin client. I can also use virtualization using Hyper-V. The cool thing about that is that you don't store anything locally. Everything is pulled from the cloud, from the center. And so let's say that I'm working on certain things, because our computing system is a state machine. It saves everything that's updated to it. So that means that whenever that you are syncing your system, just like how you sync your laptop to another system, it's going to port all the data and all the information, all the changes in the settings and so on, back to the cloud server if you're doing an infrastructure as a service. And then, you know, in the case that if that user is roaming somewhere, or if they come back the next day, it can pull it back and it creates a profile for that virtualized machine. So there are many approaches in how you can use the service and how it can be effective in, you know, convenient, cost effective, and also, you know, having more availability in as far as performance in your environment. So when you're looking at infrastructure as a service, you would be pushing out maybe software applications. You can maintain operating systems through the cloud. That means at the data center, could be at AWS or Azure. right? So AWS and Azure specialize in this. If you look up Google GCP, they tend to be more in this area right here, in development and applications and web, right? So you have some providers that are specialized in certain areas. So when you're looking for cloud product to integrate, and you always should ask the question, right? What is the liability as far as security? When you lose my data, how much will you replace? Because some clause, it would say that, you know, for every piece of data, if they lose it, they would only pay you $1 per piece, right? So if they lose 1,000 of your records, then it's $1,000. But to build that data back, because we quantify it, so let's say it takes me 8 hours to create a design, okay? And let's say a designer charges $100 an hour, 8 hours, that's $800, right? But they're only paying $1 for that lost design. So you got to really look at the liability and how you quantify that out, right? So in the case that if we have a breach and or we have corruption in data, and it exists at the data center, right? When you rebuild the data, it's cost in rebuilding that, and then also the loss of data from previously created. So that becomes a problem. Okay. Number 4, and as you go through the notes, it gives you the explanation and an example for each of these. Acme Company wants to lease cloud service to run its financial monitoring software. What type of cloud service model should Acme Company select? So you can use this as platform as a service. This allows you to, number 1, deploy your software, but unlike SaaS, right? You're able to obtain the services and it will maintain it as a platform instead of just source code, okay? The application that exists on your cloud servers. Any question? So we need to kind of know the difference in these. Okay, so here is the breakdown. Now, when you're looking at AWS, if you're looking at infrastructure as a service, when you log in today using your AWS, you would see, right? There is EC2, and EC2 have actual systems and instances. So when we say instances, that means that you can have virtual machines. So on each of the server, they would allow me to say 4 instances as free. I can run a Windows 10 or 11, that is a client OS. So I can use that as a virtual machine. I can run a Linux server, right? Like Ubuntu server. I can also sometimes run a Red Hat server. I can also run Windows server, right? That would be included with the free tier. So as you spin up the instances, it's like, you know how you extract Kali Linux and boot it up, load it and play it? It's exactly that, right? But using a remote system at somebody else's server. So with that, you do have control and responsibility in how you manage your system. So you do have to pay for the licenses when you upgrading your OS, right? Just like how instead of having it physically at your facility, it is just at someone else's facility, okay? And then platform as a service, this is often you would see that you can deploy applications using programming languages. So the most common you would see here, Python, Ruby, Node.js, Java, PHP. And then under the Java, you do see software development kit, especially like for Android or even iOS. But now Apple has been changed from Swift into a later version of Swift for their suite in programming languages. So you can run application that would be compatible for mobile devices across, right? It's just simply allowing you to be able to maintain and execute your code. Now, when you're looking at software as a service, that's an actual application like your Google Suite, Office 365, Adobe Cloud, Creative Cloud. Those are SaaS. But platform as a service, this is source code. So you can also run it as a function, which is another service that they provide. But so let's say that I I write a software for my company, right? And I want to, be able to utilize it. I can use platform as a service and then put my source code and be able to test it, develop it, and then integrate it. So Google specializes in this area often. And then they also offer SaaS as well, SaaS. This is something a little bit more recent, function as a service. So sometimes you don't need a full application. It is serverless application architecture. So sometimes you just need an executable task. When does this happen? You see this with IoT devices all the time. So I'm going to give you an example, right? You buy those smart light bulbs or those Christmas lights, and their function is just to blink, right? It can blink to music. It can blink to pattern. It's just executing that one simple task to blink, right? And so in our system, sometimes that's all we need. We need maybe a number of functions, like in farming, watering, right? Heat sensor. Those are the few things that you need for farming technology, right? When it's dry, water. When it's hot, water, right? When it's too damp, don't water, right? So when you see that, you do see some functionality, and even in advanced manufacturing, a lot of the robotic systems, its job is just to package or put a label on things or to be able to build things, right? Simple functions. So you do see Lambda service incorporated for AWS. And then when you look into Azure and other provider, you would also see. Any question? So for number 5, it says, what type of cloud service model allows serverless application architecture, which developers write functions in response to events, right? Like I said, when it's dry, right? Water all the corn, right? Or the vegetable, the lettuce, right? Or when it's hot, when it reaches a certain temperature, etc. Or even when you're looking at utility company or dam even, right? Like you've seen like industrial things where when the boat is about to cross, the bridge lifts up and then the boat crosses and then the bridge comes down. That's all the only function, right? So they built all the sensors in that, and there's mechanical and false, fail-proof kind of mechanism. But when we're looking at processes and things like that, if things are just repeated in a simple process, you don't need a whole server with 24 core to be able to do that. You can use everything serverless to be able to execute that function. It saves us time, it saves us resources, right? And then you can do it from a data center. As long as your technology have internet connection, and that brings us back to Internet of Things for automation, right? So you will see more of that with cars. Things that will transport us in from now into the future, trains, bus, things like that becomes more of like less human interaction, but more automated type of feature. So we do see that here. Okay, for 6, it says, what type of cloud deployment models require the use of technology that unifies different cloud offerings into one single coherent platform? So you might have a hybrid cloud, right? So coming back here to the notes, there are some deployment model. These are the models. So you've seen public cloud, right? If you use Google Drive, Google gives you 10 gigabyte for free, and then after that you pay. I pay for Google because all my systems at home outside of my desktop and laptop, that's Windows based, but I use mostly Android technology. So, and it syncs seamlessly, so I like it. So you can have public cloud to be able to, for storage or for other type of things like applications, Google offer like their G Suite for free. And then you have private cloud. So if companies have provisioned private cloud, can you name some big company that you know that owns private cloud? Any social media company has private cloud, right? Like your Meta or Facebook, they have what, 20 something locations now around the world. So they started in Mountain View, California, and then expanded. Same thing with Google. So you see private cloud that is provisioned specifically for Meta, right? They have this one company that contracted, it's based out of New Jersey. So why do they house it across the country? Again, right? In the case of California is impacted by earthquake, they do have the data across the country. And then they have it in Denmark, they have it everywhere because you got users everywhere. And also cloud sometimes is measured by distance. So you don't want a data center in Africa when you're in another continent. So you want it to be in proximity because your connectivity is still considered, right? And then also time span. But if you're operating in different continents, like you have companies in Asia and Europe and North America, then you do want to have data center accordingly for your locations. Okay. And then you have community cloud where it can be shared. So let's say that I don't want to have a completely private cloud. I might not have the money to support that. That tends to be for larger enterprises, right? I can be able to support that with maybe partnerships, or it could just be for like a certain group of people or maybe a city, a region, etc. So you are designated in like a community platform. And then the hybrid is the answer for that one that we just looked at. So it is a blend of both public and private and or community. And so you do have a mix in that. So that's why they call it private. So you have some equipment that's provisioned for private and you do have some that's public. A lot of companies choose this route only because the public side is already freely available by the service provider. Like for example, right, if you buy a Microsoft license, you automatically get a OneDrive option. But in order to integrate SharePoint, which is for the larger enterprises, right now they call it OneDrive, but in the back it's still SharePoint, that saves everything from your email to your personal data, etc. You do, so you integrating some, some SaaS, right, private option along with some public options. So you have a mix of things there, right? This is different than what you see in the service, right? Service is like the type of things that you want to choose for your operation. And then the structure and how you use these servers are going to be your deployment model. And as you can see, Amazon has a bit in everything, right? Nobody scales like Amazon, so they are like leading in as far as, cloud technology. Amazon has everything that you need for AWS, and it's hard to beat the price, just like how some of the products that they carry. The only competitor that you see in this area is Microsoft or Azure.
To ask you, with Amazon, they say in some places they deliver packages through using drones.
Yes.
Is that part of the cloud?
So drone control is part of their automated systems, right? And it is for the infrastructure. Their cloud area is specifically for housing people's data, application, and so on. It's kind of like rent a storage. You know how you go to and rent a storage? Let's say that your house is full of things and you want to borrow someone's space to put your car, your extra belongings. It's like that, right? So we rent a server to be able to store our application, our databases, our customer information, and so on, right? So cloud product is more like that. But yeah, drone technology, they probably integrated some of their data center resources for that. Yeah, it's only available for the fly zone for drone area. Some of the areas here are not, right? Depending on how you zone it. Even some rural area you can't fly. So all right, so here is a good comparison that you can see in security operation, and this is the area that we focus in, right? Just the basic information at the top, but you really want, so every service that you see requires that contains data, right? If you have infrastructure, you got data like user accounts, right? Storage, archive things, platform, you got source code, right? And then application data. So anything that's input by the customer for the application, that's stored as a data. And then you got software application for SaaS, right? Like I can generate a Google spreadsheet. I would be able to write a document like a memo to my company. That's a form of data. And all of them have applications. So you do see that they all have equivalent. Some are more emphasizing, as you see how the color is highlighted here, right? But when you look at the responsibility, infrastructure as a service, the majority of your responsibility for maintaining and securing is in IaaS, right? And then for platform, usually this is mostly vendor responsibility. We can't say there's exception, right? And then for software as a service, this is a shared responsibility. So you do see like a 50-50 in that area, okay? So if you have malware, you have ransomware, whatever, and then you're pointing the finger, you're like, oh, it's your system, right? So I was reading the policy about pen testing clouds, AWS, right? When I write these things, and I wonder about, so in their term is that AWS noted that these are the things that are permitted, and I put the link on there for you. These are the things that, so you cannot do distributed denial of service, or and if you want to simulate it for red team practice, you need to notify them 2 weeks in advance, right? But in the case that if you are impacted, right, but they are saying that you are permitted to do certain things. However, you cannot damage their actual server. So if you're destroying their OSs, right? Like let's say that I planted a rootkit and then I just completely destroyed their system, then I become responsible. Now, now I'm abusing the system, right? So they have every legal right to pursue me. So you kind of have to take a look at the legal side and how you're testing and deploying your systems, and then planning out your security. Okay. So for 7, it says, what type of operating environment require cloud customer to divide responsibility between one or more service provider and the customer's own cybersecurity team? You would see a shared responsibility model. So let's say that, I might have a hybrid environment, or I might have a cloud environment where I'm 50-50, right? Like software as a service with my service provider. Or sometimes it will be 70-30, right? Like I would be mostly responsible for 70% infrastructure as a service, and then they are responsible at 30% for their hardware. Like when drive goes down, right? They're gonna make sure that's available. When power goes down at their data center, they're gonna make sure they have backup power. So there's some responsibility on their end to make sure that their system is available and running and maintained in good health or performance. But I'm still responsible for things like, potential attacks, protective of, my systems, like operating systems. So I need to patch it. I need to update it. I got to make sure I have proper access control to my systems, my server roles, my features, and so on for the infrastructure. And when you look for security job, you often see this term DevOps or SecDevOps, right? So when it's SecDevOps, that involves security and development operations. It is a way to really unify the process between development and operation in agile approach. If you've taken classes that talked about project management or software development, they often mention like different type of model in development. Agile approach is the most common, and this is a way that we can test as we develop, right? Traditionally, what you see for a long time is when company beta their software product is when it's already finalized and internally tested. So that means that I write a program, let's say a game, and then I would test it with my development team and my company. Once everything is passed, then I put it out to a group of users, right? Those are beta users. And then they would give me feedback. And so I would try to edit my software and improve it so that way the mass public can buy my software or use my software, right? So that is a waterfall approach, and it's been around for a long time and some people still use it. But the downside is if your project flop, right, at the end, you will not have a good product for a long time because you have to go back all the way to the beginning and then redesign, right? So in agile approach, we are able to test and release as it comes. So whenever that you know how I always tell you guys, make sure you update your Kali when you first started, right? And then you're like, oh, I just updated it yesterday. Why am I updating it again? But guess what? On Git, it changes all the time, right? As developer, when they change or they debug the features, they change the version, and that allows them to test and release quickly, right? So you don't have to go back and redesign from the beginning. You're able to look at some of the flaws and fix the problem, be able to release it. So you constantly have newer version, and this is allowing us from the security side to be able to patch better things, right? This is really important when you're looking at like firmware, issues with IoT now, also industrial automation. So it becomes more of an automated collaborative process where your frequent updates, you don't have to wait a long time for an update, right? So when I first started teaching, and I found teaching by default, right? Like by accident, actually. I used to tell my students, so back then, people, security software company or antivirus at the time, they would release their updates midweek, right? So if you scan your systems or your server, let's say at the beginning of the week, you gotta kind of wait till like Wednesday or Thursday when they actually release like new definition for virus or malware, and then you would try to patch it at the end of the week to get ready for the next week, and you would continue to do that. But the downfall in that is if you have something in between that timeline, then sorry, right? Like you're gonna have to wait. Something would be disrupted. So you don't really have a streamlined process for frequent update. And even if we have frequent update like this, we still have 0 day, right? We know that because there is flaw in a lot of the things that we built upon for technology. All right, let me move this down. Oops. So now we understand what DevOps mean. Okay. So API, let's talk about that because you're using that today, right? And when you're using cloud, when you're using security tools, definitely you're going to incorporate API. Application programming interface. It is a program that talks to another program, okay? So in order, let's say that like some of my students from CIS27, they're like, oh, I saw that, you did this in your lab. So you can have Nmap running and another application running using an API like Wireshark together, right? Sometimes they work together, and in Python, that's great. A lot of the application that we create, we're able to use API, and you use API every day. For example, you are playing a game and you're trying to log into it, and it asks you to create a credential, or you can use your Google account, your Gmail, or your Facebook, or your Instagram, right? You see the logo there, and then you just click it because you already authenticated to your Gmail or your Instagram or your Facebook or whatever platform you use, right? TikTok, etc. That is an API feature. It basically ported your credential from one application and connected for the next application, right? So it is two applications that's combined so that way it streamlines the process for you. So when you're using API, it's important that you don't share your API keys because it often is tied to your session, right? your credential or your login and the service that you're using. That could be sensitive, right? Contain sensitive data. You need to make sure that each user has authentication account and also correlated API keys. So this is why when you're doing AWS today, right, you would see that IAM is a feature for Azure and AWS to do access control. As access management, it allows you to create user accounts for whoever that would be accessing that cloud platform, okay? Whether to manage or to use, right, or to test. So we want to have individual user, right, and individual keys for API and for applications. So if you're using many applications, you got to make sure that that's integrated. And then the services. You need to make sure that we control this securely in a way that we associate rights, right, with each API. Now, we understand that we always follow the least privilege in no matter what we do, permissions or system rights, right? So in system rights, we want to make sure we think about why is this API used, right? The intention behind it, and then map it out to like the user or the groups that you are signing it to, okay? You should never transmit your keys over unencrypted channels. Why? Because they can run network monitoring tool like Sniffer and be able to obtain your payload, okay? And it's a lot easier to take the keys than brute force the keys, trust me, right? It's kind of like I tell you to go into my house, right? And then you're gonna try to take my keys and open the door. That's a lot easier than trying to figure out how to break the lock, right? So you would see that transmitting keys over unencrypted channel is a big no-no, right? Not a good practice for API. Do not store API keys in unencrypted form. So make sure that we always use some form of encryption when you're transmitting over email or whatever it is that you're passing the key through the web. Make sure it's using encryption. Ensure the keys are removed from the code on the public server. We don't share this, right? And if you do, you disable that key and that account, okay? If it accidentally leaked somehow, right, we need to make sure that that gets disabled immediately because someone gets a hold of that, right? If it is a cloud management API key, you're in trouble, okay? Because someone can just totally hijack your cloud. And yeah, we don't want that kind of 911 situation. Okay. So why is this important for you in security and as an analyst? Okay, sorry, maybe move it so you can see. Your data, why do you care about cloud infrastructure and how you should monitor it and how you should secure it? The historical and the current data gives you information about the rules that had been broken or policy violation, incidents that had happened or currently happening, and then how to fix some of the problems, troubleshooting tools, potential issues, right? Potential breach or occurrences that can cause disruption or other type of security incidents potential. So it's important, just like your physical server at the facility, you need to monitor a remote set of servers that's called the cloud. Okay? So the more well-versed you are in this area, the more beneficial it is for your professional career because, as you know, right, many companies use this cloud. So when I wrote the lab, I had the intention to use a lot more tools, but as I look at it, the step just got longer and longer. So we'll come back to some of the tools, but we are gonna use these two today. So Scout Suite and PACU, right? They're both written in Python. So Cloud Suite allows you to use it for different type of cloud. So you can use it for AWS, Azure, and GCP. When you look up their information and also like just in general how people use it and when they document it, you often see more AWS because it's just more of a popular product. But you do see some instructions on how to use it with your Azure and GCP, your Google Cloud Platform. Now, this particular product, PACU, right, PACU, it is specifically for AWS. It is an exploitation framework. So when we say exploitation framework, that's like Metasploit and some of the other framework. It's not just one tool. It's equipped with modules or Python files for different functionality. It is really designed for red team or offensive security testing against cloud environments. So this is definitely an active type of scanning tool, okay? Then you also have Prowler, which is used for AWS and Azure. This is more of, this works as an assessment tool, that's good. This also works as an assessment tool. This allows you to also audit. So from a security professional standpoint, you want something that allows you to assess, right, the issues with your system. Also go back and check to see if things are in place. So audit is really a way for us to look at what's there and what's deficient, what's the gap, and how we'll be able to fix it. Looking at incident response, so in the case if you have a breach or a leak, and then continue to maintain and monitor, and also hardening and forensics. So it is more of like an overall suite. Now, when you look at open source tool, they are not perfect, right? There are times that, you know, different, and when they change up the release, different functions change, right? So make sure that you read their documentation carefully, right? Do a little bit of logically troubleshooting some of the issues with, you know, maybe if your function doesn't work, if you're getting an error, right? Look at your error and try to think about like, why is it an error? Is it because I forget to access a certain directory? Or is it because it's actually an application error? And then you can also research like the thread. GitHub is pretty good at you know, they put stuff on GitHub now. So a lot of the times, you know, people would post on there if they're running into issues. So I spent like maybe a good hour and a half troubleshooting this today because, you know, it's great. A lot of the things like on the internet and even like I've used Scout Suite before and they change it up, right? Like the execution command used to be uppercase, now it's all lowercase, it's in a different directory as Python version changes. So, you know, that's why like sometime when I reteach a class, like maybe a couple semesters later, you do see the changes all the time. So if you are revisiting some of the tool down the line, I recommend that you test it. You go back and read the documentation and you try to see if, you know, what's the update in it, right? Any questions? So on the notes, I provided additional tools for you, and there's also links for you to refer to. Like I said, right, in our class, we're going to spend a week on this, a week on that. I encourage you to go back and practice, right? That's why I'm choosing to use Kali Linux virtual machine instead of forcing you to use the one that I customized. So that way you have access to it all the time. And then you can always create your own virtual machine if you want and add all the tools that you want. But Kali already have a lot of the things you can add to it and then try to test it and run it so that way you're more comfortable with it. And having it on your resume is going to go a long way because sometimes you're going to have companies are looking for someone to be expert in certain area. And especially if you're going to go for pen testing or red team, right? This is going to be something that you want to expand on, right? Okay. So we talked about API, right? Make sure that we are always checking our logs, especially for, you ever hear the term SOC or SOC, right? That's Security Operations Centers. When you are hired as a specialist or an analyst, that's where you work mostly. Where you operate is at the Security Operations Centers. And that could also be at the data center. That's part of the data center, but it is a different division under IT for most enterprises. So, and if you work for like a security management company, like a company that manage people's security, like systems and so on, you would also either work under SOC or be affiliated with it. Okay. Some of the ones I didn't mention are here, right? There's some that's specifically for a certain product like Azure, and then there's some that would have additional feature. If you're doing PowerShell, Microburst and PowerShell is probably one of the better ones. Dumpster Diver, I've used this before, but it's mostly for like key capture. So if you are key hunting, you probably want to use Dumpster Diver. And so on, right? And it's not just limited to this list. I'm sure that there's additional tools, but I dug around quite a bit to kind of give you some of the common tools that you see. So check those out. Okay. Any questions? Okay, let's talk about cloud brokers or cloud security brokers. So you might hear the term CASB, right? That stands for Cloud Access Security Broker. These are just software that is going to be the intermediaries or the in-between software, the middle software that is connecting the client to the providers. Okay. And you have some option in this. So you can use an inline CASB. This is going to be within the connection path between the user and the service provider. Okay. It's often you would see this as a hardware appliance or some kind of system that would route, right, directly to that service provider. So just think of it like maybe I have a router that specifically set route for my connection to Microsoft, right? You need to make sure that you configure, right, that appliance and also your endpoint devices like your desktop, your tablets, and so on, or even IoT devices, right? That's connecting to the network. And one of the key area for inline CASB is that it's gonna have requests. You're gonna have, it's basically queuing the request before it sends it to the server systems on the cloud, right, for the services. So with inline CASB, we need to have proper configuration, the appropriate hardware, and then the configuration of the connected systems. Now, cloud is dependent on network connectivity, so your bandwidth is important. So, and then we want to also have not a single point failure, or also a backup way to connect in the case that if our main connection for our internet service provider goes down, right? So you do have failover servers, that would be some kind of backup locally for some intermediate and also connection. Cloud, with cloud, that people tell you, right? Your data is backed up many, many times. So even if you delete your account on the systems that are on the cloud, it exists in many iterations that were backed up. True, but we cannot rely on that, right? We cannot rely 100% on the service provider backup. You got to also make sure that you maintain your backup in the case that if you can't access the service provider because you have down connection, then you do have some data. Okay. Now, people might choose like satellite connection as an alternative connectivity way, or it could be many things, right? There are new technology now for satellite, and arguably, right, to me, right, I'm old school with network technology, and satellite been around for a long time. A lot of my friends are like, oh, you should get this because, Elon says, and I said, well, it's still line of sight. I don't care where you are in the world. If you have a cloudy day or some object in the way, you're still gonna get poor signal. I bet you on it, right? Even if it's able to amplify the signal in a certain way, you're still gonna be restricted to that. Unless like there's some crazy new technology that we didn't know about, but it's always been like that for satellite. Okay, we can incorporate what's known as API. We talked about that earlier. That stands for Application Programming Interface. This is a way that we can connect two programs together, like one program talking to the other. So API doesn't directly interact with the user, but it is directly working with the service provider, or they would provide the API itself. So you don't need to configure for the user systems. You can block the request that violates the policy. It is different than this one. When the inline, you are going to receive the request. So the downside in this is you might have buffer overflow here, right? But in the second option, if you're using API-based CISV, what will happen is if it is not meeting your policy, it's going to kick it out. It's going to block it. So that's one benefit. Now you have to monitor the user activities. So the systems that are connecting and the users that are using your cloud. And then you are gonna also look at whether it meets the policy that's set for your cloud service. So if I have a lot of resources, right, to accommodate cloud, I would consider using inline, right? API is more of an integration with software, and that can be, incorporated with filtering out some requests along with monitoring activity. But we monitor activities no matter what, for security reasons anyway, right? Any question? I'm sorry if I scroll down too far. Let me. It's actually just a short unit, so you will have the time to do your lab. Okay. So that kind of covers all the main points that I want to highlight for our cloud computing chapter, right? So where can you find this information? You can find this information in the section of CASB on page 5 of the 5. So this is one of the shorter unit. I wanted to kind of chunk it where it kind of falls together with the specific technology and all of those things. Okay. But go through, read over some of the the concept and then terminology, get familiarized with those and understand the differences and the practices for securing cloud. Okay, I'll let you go to break shortly, right? But for today's lab, let's address that before we take a little break. Okay. We are going to use AWS. I put down the free tier account information. This is going to require an input of a credit card. It will not charge your credit card. I tested it many times, right? I've used it over the years. They allow you to have many credits and you are allowed to use it for free for 12 months. So right after this lab, you can just close your account, disable it, never think about it again. Great. Like I've done that, right? I've taught one of the class that I had to use AWS during COVID online, right? And I did that with the student. And then, and even I left it out for a while. Then I came back to it and it wasn't charged. AWS Educate account requires no credit card. When I log onto this, it just gives me a lot of training module. This is really good if you want to get like certification from AWS for free, learning some about their technology like EC2, S3 buckets, those things. I encourage you to, like this summer, if you have nothing to do and you're bored, just spend a few weeks going through those modules. They did reach out to me trying to let me know that I can build some pathway and courses in AWS. I know RCC house some of the AWS courses and for their technician pathway or whatever, but we are building out some stuff for Amazon, right? So we need to, I would encourage you to use a free account, even though you have to put in a credit card, and you don't have to do it tonight in the case you don't have a credit card. I realize that, right? But because it is going to be a little bit more restricted with this, but see if you can sign in with this account and would get the same options where you would have AWS access, right? I will log in and show you what that looks like. So, you know, the education side, it is free. You're not required to put in a credit card, but it might not look exactly the same. That's my point. Okay. We are going to enumerate our AWS account somewhat, and I want you to also, when you do this outside, make sure we look at this page, okay? And it tells you what is permitted, right? I was looking at some of the tools, and we are mostly focusing on S3 today. Now, when do we use S3? S3 is common. You guys ever get like, you know, when you reset your password and it sends you those, you know, OTP code or whatever, or those message that reminds you that your bill, your payments is posted or whatever, right? Those you can automate a lot of that to your Internet of Things or your mobile devices through S3. There are many ways that we can use S3. You can also deploy things. Basically, it is a storage format, right? So these are the type of products that you are permitted for pen testing, right? The prohibited is anything that's DNS, like DNS farming, hijacking, poisoning for their product, especially Route 53. Along with denial of service. So in the area of denial of service and flooding, because it actually physically impacting that server, right? Buffer overflow, all of those things, then it's not allowed. But here it says S3 buckets is strictly prohibited. I did have a little small exercise on S3 buckets, and I hope it won't be a big deal. So it is very quick. But if you do want additional simulation, let's say that you want to test phishing and other things. So network stress test is a form of DOS, right? When they say stress test, it's really you just dumping a lot of requests to your system. You just need to make sure you ask their permission, right? What will happen is they will give you the time span on how you can test it. And then there are many things like malware testing. So they can give you like a protected environment or a control environment where you can do that. So I put some link information on here. And so you can check it out. But we'll start with creating the account, and then also you can download Kali Linux. So I'll stop recording and then we'll take the 10-minute break. When we come back, we'll start the lab early because I suspect that you might run into some issues. Okay, let me stop.